Hello, good afternoon. This is March the 27th, 2014, CISG114, Section 1, Web Technology and Life. Today is date number 12. You look at it, it's actually date number 13, okay, in week number 7. So let's get started. Welcome back to this class, the second class in week number 7. The last class was self-regulated learning, so I need to do some conclusions after the basic sequence of today. So let's get to the conclusion. Let's get to the, not conclusion part, let's get to date number 13. Now if you look at date number 13, we are in the topics called taxonomy, okay? This is a very interesting topic. If you look at the title of this week number 7, it's tagging, it's taxonomy, it's social web. Tagging means to give a name of a specific label in your specific web page item. Taxonomy is just like the categories. And social web, you know, today we live in the World Wide Web, largely hooking people up. So let's get to something very interesting, okay? Now get ready your note-taking activity. We would like to make sure that you get hooked up to this topic, because next time we visit Team Berners-Lee links web open linked data, and then we use the Donations Airline MX370s tracking data to help explain that. And unfortunately, we noted that the airline now landed in the Indian Oceans, and you know what happened, right? The airline, when it's landing in the Indian Ocean, that means it crashed into the oceans. And we just have to say that the word right for that. And so let's together today to continue with linked open data, what it is. Now, please get ready. Understand this very important part. 3 minutes, 42 seconds.
Linked open data. What is it? Or why is it good for you as a memory organization? Put yourself in your user's shoes. Say you want to find out about that painting of Venus standing on a shell. You probably search on the word Venus. You'll get lots of results. Venus, Venus, Venus. And after a while, you finally reach the right Venus on an individual website. But what if the web service could help you from the start? First, by disambiguating your search, and then by connecting all kinds of relevant information, updated dynamically within the same web space. Well, linked open data makes this possible. Here's how. Tim Berners-Lee, the inventor of the World Wide Web, asked us to put our information as documents on the web, and so we did. Lots of information today is available on lots of individual websites. And then he saw the next step forward. He asked us to put our information on the web as raw data, because raw data can be linked to other data. That generates connections for the user and puts them in touch with a much richer network of information. But to make that happen, you've got to do 4 things. First, it helps if your data is openly licensed. If it's not open, it's not easily interoperable. Second, you need to put your data on the web in a certain way, so that the connecting links are present in their simplest form. And each of these links is represented using the Resource Description Framework, or RDF triple, because it's in 3 parts. And all these triples will interconnect. Third, when they are online, they need a unique address, a uniform resource identifier. Fourth, you need to put them online following the standard Web Resource Protocol, HTTP. And hey presto, your linked open data can be connected to all other linked open data, creating a rich network of information, making connections you never knew were there, linking knowledge in a way that's never been done before. So why is it good for you and for your users? When other data connects to yours through inbound links, your website rises higher in search engine results, and your data is enriched by all those linkages and is more visible. But also you and others can easily build applications based on your data and the data of others, so you're being found more easily and you're sharing information that's much more complete. And the more useful your information is, the more visitors you get. The more traffic there is, the better your web statistics and performance indicators. Make your trustworthy metadata linked open data while the space is still available. You may become the canonical reference point. We think this is a win-win situation both for users and for memory organizations. The contract that Europeana has with its data providers, the Europeana Data Exchange Agreement, centres on open licensing as a way to facilitate this. This use of open data has been endorsed by the Europeana Foundation, the professional associations representing our memory organisations, so that all our public sector information contributes to the real power of the web.
Okay, now let me give you at least 2 to 3 minutes time to capture what you heard in this video. Of course, the name of it is linked open data. And the question is, what is it? Try to answer these questions with that, say, 1 minute of you taking down the notes, 2 minutes discussing with your partners, and get some ideas of it. If you need some paper, let me get you some paper. Now, that is a very interesting question, and also the topic, okay? Answer service question simply it's open data. And what is exactly is open linked data? It's meant to be a very brief discussion to help you capture some important things about open linked data. What are the major characteristics? You may not understand all the intricacies, but the key points is open linked data. What is it? So make sure you put down some characteristics of your understanding after watching this video. It's called linked open data. What is it? You might ask this question if you like. What exactly is a linked data? What exactly is an open data? Now we have open linked data. So what kind of examples can we give? In the video, we seem to have to watch a number of examples, but the question is, real-time example, easy for us to understand, okay? And remember, this is the video we watched last time, introduced by Tim Bernard-Lee. Links web of open linked data. All right? So do you have any idea on open linked data? Just give some idea, it's good enough. Open linked data. What do you remember about video?
First, we need to have data,
Data.
and then we link together and have the address to that link.
All right.
And we will group the data and to apply in application.
Okay. And what is the adjective we use to describe this type of data? You don't need to give an answer. Just think about it. Okay? So, do you have any ideas on the linked open data?
Yes, it has to do with the structured data,
Okay.
which is interlinked.
Okay.
It's normally on the web in the form of HTTP or RDF.
All right. Wow, very technical terms, right?
It allows data from different sources to be interlinked.
Oh, that's very interesting. These allow data from different sources to be interlinked. Very good. Do you have any ideas? What do you get from the video?
I think it's a web technology
Okay.
and it lets the information can share among the people.
Right.
And people can get access to the information more easily.
Wow, that's good. That's the meaning of open, right?
Yeah.
That's very good. We got a lot of good ideas. Thank you. What do you think? Yes, Lee? Yes. We got a lot of very interesting information.
I think it is a useful way and much easier for us to find the information.
Okay,
Yeah.
right. Okay, that's good. That's good because the information are interlinked. Lena, do you have any more to say? Yes, try the best.
I think
Yes.
that is
It's okay. Just give some ideas. Yes.
help us know more.
Okay. Open linked data. Help us know more. Thank you. Do you want to say something, Winston?
I think it can share information more easily.
Okay, that's an interesting thing. So what do you think, Joanna and Carol?
I think it means that data are more systematic and we can easily retrieve from the internet.
Okay, more systematic. Okay, that's very interesting. Do you want to say something? Okay, so we come to this table. Do you have anything more to add based on the ideas collected so far? Key ideas, do you have any?
Maybe some government,
Okay.
they will publish some information online so the public will know, and
Yes.
maybe that's so-called the open data.
Okay, okay, thank you very much. It's the data released by organizations like the government. They help us understand more information, and these informations are made public through some addressing, make sure that it's open in the sense and they can be interconnected. Now let's watch interesting video on the idea what is linked data, okay? What is linked data? Let's try to see if we can understand more from this video.
This is a quick introduction to the concept of linked data. It's a fairly non-technical introduction, so even if you don't know anything about web programming or how the web works, this should still be fairly useful to you. So you may have heard about linked data recently in the news because Google and Facebook are starting to push it out into their products. So the first question, I guess, is what is linked data? Right? What is it used for, and how do we produce it? Now, if we go back and think about data by itself, Right? There are many different types of data that we use today. There are images, there are things like Excel spreadsheets, there are videos of a variety of different things happening all over the world. There are websites that include pictures and text and links to other websites. So there's a lot of data that's accessible to us throughout our lifetimes. And one of the really cool things about the web is it put that data out there so that it's really easy for us to get access to it. So the web allows us to mix pictures with text, with charts, but not only that, it allows us to link from one document to another. And using these links, we can follow them from one document to the other and figure out a bit more about the subject that we're reading about at the time. So there's this really cool discoverability aspect that the web unlocked between all the different types of data that we have. So this is really a great thing for humans, but computers are still kind of back in the dark ages. They don't understand what's on these web pages. They understand that this is an image, but they don't understand what the image is depicting, when it was taken, any of that information. They understand that this is a link, but they don't know the relationship that this link has to this web page. They don't know if it's a random link that's going to take you to a spam site. And they don't know if it's an actually useful link that's going to take you to, let's say, another Wikipedia article about it. So the big problem that computers have with data today is that they don't understand it, truly understand it, in the way that humans understand the same information on a web page. So what web developers tend to do, they spend a lot of their time doing, is taking these web pages and deconstructing them. They take the little bits and bytes out of the page and package them up in a way that is understandable to computers. Right? So we do things as software programmers, as web developers, that take the pieces of data on the page and package them up in such a way that express things like names and birthdays and moods and locations, just so that computers can understand what we're talking about. Now, there are two problems when it comes to linked data on the web. The first one is a common format problem. It's a packaging problem. What's the best way to express this data on the web? Today we have HTML, and JSON, and XML, CS, separated value, CSV, and RDFA. So there are a variety of different ways of expressing data on the web. And then the other problem is, how do we link all of this data together? Right? What do we use to link these pieces of disparate information together on the web such that machines can understand it? So the easiest way to kind of represent data to computers is in this property value mechanism. Right, so this kind of looks like an Excel spreadsheet because that's kind of the simplest way of representing the information to a computer. So we have properties and values. So this name property has a value of Frank. This birthday property has a value of January 3rd, 1985. This mood property has a value of happy. So this kind of creates this island of information that the computer can kind of understand. It knows how to process it because it has a pretty regular format. The problem is that it's not linked to anything, right? It's kind of out on its own, and there's no way to figure out what Frank's relationship is to the rest of the world. So that's where linking comes in, right? If you think back to a website, websites have links to other websites. We need the same kind of thing for our data, right? So we have this description of Frank, this data, and in it there's a piece of information that's actually a link to other data, right? So now we know that Frank is linked to Jan in some way. And if we look at the property, it's the knows property. Frank knows Jan, right? And that's a pretty powerful thing for a computer. The computer can now use that information to figure out that there's a relationship between those two. Another way of representing this information is not necessarily an Excel spreadsheet, but this kind of structure called a graph. Now, Google has their knowledge graph, and Facebook has their open graph. But at the most fundamental level, they're the same thing. It's a graph of information where each node is kind of a subject, something that you're talking about, so like Frank or Jan or Tim. And each subject has information hanging off of it. And each subject can also be related to one another. So Frank is linked to Jan, and Jan is linked to Tim. The way Frank is linked to Jan is through a nose relationship, and the way Jan is linked to Tim is through a parent relationship. Right? So if you were to ask a computer, who is Jan's parent, it would go and find Jan, and it would follow the parent relationship and say Jan's parent is Tim. And that's how this graph of information gets built. And this is all linked data, it's all linked together. And the really cool thing is that these green lines represent the borders of websites. So this is one website, this is another website, and this is yet another website. So linked data is data expressed on a website that can traverse via links to other websites. And that means that the internet, or the web rather, becomes this global information repository where you can ask the internet and the web basically questions like who is Jan's parent, and it would be able to start on one website, follow the link to another website, and answer the question for you. Now, we have this kind of cool thing on the web, this universal ID mechanism called a URL. And computers really like to be very specific when you're talking about things. So if we go back to this graph, computers are going to have a hard time with this information because we're not specific enough. We're not specific on which Frank we're talking about. We're not specific about which Jan we're talking about, right? Or even the words and the terminology that we're using. Right? So what we end up needing to do, at least with computers, is we end up needing to use URLs to identify things. Now, this works really well for us as well. So the main thing that you use to go to a website is the URL to the website. If you want to share a link with a friend, you send them the URL. And you know that when you send them that URL, it's a universal identifier, and when they put it into their web browser, they're going to see the exact same thing that you're seeing. So we want to use URLs for everything in linked data, basically. So to a computer, this is what linked data looks like, right? There's a URL, which identifies Frank. There's a URL that specifies a nose relationship, and there's another URL that specifies Jan, right? Now don't be afraid. You're never going to see the information in this way. But for a computer, it's really useful because now it knows that it can start here, follow this link, and end up here, and find out more about who Frank knows. This is really how the global knowledge graph gets built, right? Piece by piece. Every single website publishes their data. All the data links to one another. And search engines and web crawlers can then use that information to answer interesting questions like who is the president of the United States, or how many people live in Libya, or find all of the local offices that are up for re-election this year. So there's a lot of information out there that's floating out there that's not in linked data form, and if we put it in linked data form, computers are going to be able to use it to make answering these questions much easier. Two examples of that today is Google and their knowledge graph. Google, if you do searches in Google, they now utilize linked data to answer questions directly. You don't have to go to a website to figure out what the answer to the question is. You just ask it directly and it'll answer it for you. For example, converting feet to meters, or if you want to figure out what the President of the United States birthday is, you can ask them. You can type that directly in and it'll tell you what it is in the search result. The other company that's really using linked data is Facebook through their Open Graph protocol. So Facebook asks people that create websites to tag information in the web pages so that computers can understand it. They use something, a technology called RDFA to do this. But basically what that does is it highlights pieces of the page that are important to a computer so that the computer can understand what the page is about. Right? So linked data is not this kind of far off concept. It's something that's being used today. Now, if you want to find out more about linked data, there are two websites that are pretty good that you can go to. The first one is jason-ld.org. So this is a format for linked data on the web. And the other one is rdfa.info. Both of these websites have resources for finding out a bit more about linked data and how it's used and created on the web. This entire video is released under a Creative Commons Attribution Share Alike license. That means that you can copy it and share it with your friends, remix it as much as you'd like without asking permission. If you have any questions on this tutorial, please contact me. This is my Twitter handle, and I'm also on Google+, under Manu's Morning. I hope you enjoyed this introduction to linked data, and if you would like to, there are some follow-up tutorials on JSON-LD and RDFA as well. All you need to do is search YouTube or Google, and they should pop up.
Wow, this 12 minutes of introductions of linked data seems to be understandable, but a lot of these are for technical persons, okay? Although he said, you do not need any particular technical background, but I think the core ideas are already there. So now, may I invite you to use 2 minutes to put down 2 important core ideas you obtained from this video. What are the 2 important core ideas you got from this 12 minutes introductions of linked data? So before we continue, try to do that. 2 important ideas. So don't forget the answers provided by each table at the very beginning. It's very sensible. And you're trying to put into understanding the video you just watched. You try to type in questions to Google. What's the birthday of the United States of America's president? What do you get? Have you ever typed in your questions on your Google search? What is the birthday of the United States of America's president? What do you get? Now, I suppose many of you have already put down some ideas. So let me give you 1 minute to try to put together and share a little bit more before I will call back in Bernalise again to help us to understand better. Okay? The idea of open, linked data, the implications, and the core concept behind this. Yes, very good. It's so convenient that each one of you has a smartphone and you can use it in the cloud to search for information. So what are the 2 core ideas? Link, yes, link. This is what we call raw data or some finished data. Yes, because the type of data. When you see the links over there, it's very interesting. Okay, now I assume each table has already got some core ideas, and based on the 2 videos, you got pretty good ideas. Okay, the first one is what is open linked data. Okay, the second one is what is open data. So what is linked data? Not open. Okay, the lecture is open. Well, remember, we started discussing this topic last time by showing you Tim Berners-Lee's ideas of the next web of open linked data. And today, we just talk about open linked data and linked data. And so, it should be good for us to come back to Tim Berners-Lee and try to put all we've learned together in this class so far, together with the video produced by Tim Berners-Lee last time. And if you look at the name of this video, we have a new term here, the semantic web. Semantic means meanings of something, okay? The web which has meaning. And the web which has meaning is actually referred to the data. That means the data has meaning. So what exactly is a semantic web? So may I have your attention, please, ladies and gentlemen? 8 minutes. Tim Berners-Lee.
From the early days when very few people knew about the web to 30 years later, when a lot of people knew about the web, where in that steady exponential growth would anybody say that the web actually happened? There's no one. It was an explosion. The explosion is still happening. The semantic web is in the same phase. If you talk to certain groups of people, they're very excited, completely won over their own working using semantic web technology. Other areas, they've heard about it, they've got an agenda, but they haven't really got time to go and do it. But on the other hand, you can see that it's got this exponential, that it's locked into this exponential growth path. The web, in the first place, was something which solved a particular frustration I had. It scratched an itch that I knew that we could make life a whole lot easier here. The web data, semantic web, same thing, that frustration that I can't pull that data and pull other data and then connect them and see, oh, that's when do these publications chronologically fit in with these events? Or where are all my friends compared to all the places I like to drink coffee? Where's the next coffee place to a friend that I'm going to take out to lunch? That's taking information which is out there in a form that can be reused and looked at from a different point of view, combined, queried, sliced and diced, all the things that we do. For example, when we download bank statements into a piece of software which allows us to do with our finances, bam, we summarize them, we graph them, we see how we do from year to year, we pull out our taxes from them, we do all kinds of things, lots of different views, and we have software which is very specifically written to allow us to do lots of the sorts of things we expect to do with financial data. So now the challenge of putting data on the web in general is that this data is going to be about all kinds of things. So I'm going to want to pull out my financial data and then look at it in the calendar view so that I can see what I was doing when I wrote that check. And then maybe I'll need to figure out, to do that, I'll need to put in some photographs, and having put in some photographs, I'll be able to go from the photograph to who is in the photograph through my address book, maybe through the organizational structure of that company or the project they're working on, from one domain into another. And then it's projection of that onto, well, if this need, what about all these other people who deal with a lot more data, who have much more serious questions to ask on Monday morning? In the life sciences, there's a lot of excitement about using about semantic web data. I don't want the next serious urgency to happen until the the doctors and the emergency technicians and the rescue crews have got the ability to look instantly at all the data involved, even the data which was not part of the study of diseases. It was a study of air traffic, but I want them to be able to, when they study this disease, to go and look at air travel patterns. I want them to go and look at nutrition patterns. I want them to pull in whatever data they need in order to be able to stop the virus before it's too late. The data web, like the document web, involves standards. The web has HTML, cascading style sheets, and so on. All these things are enabled by open royalty-free standards, same on the data web. Whereas you represent a document in HTML, you represent data in RDF. RDF is to data as HTML is to documents. That's been defined for several years now. And for some companies that are using some web technology internally, they're getting the we can move so much faster. This is very flexible technology. If we had been using conventional database technology, we wouldn't be able to change our business model so quickly. We wouldn't be able to change the sort of data that we're carrying about our products and customers so quickly. For scientists, the aha moment will be when they've read about the people that they were interested in. They were curious about exactly how the person got to that result, and then they found a link from the paper to the data, and then they found they could just reproduce the processing of the results immediately. I think that's a step which a lot of funding agencies are pushing towards. I know certainly in the US, pushing to say if we're funding you, you have to put your data out there. You should put it out there in a standard format because we paid you to make the data, and you may have published a paper which were based on some results that you noticed. Somebody else may want to do very much of a transverse cut through your data and everybody else's data. We need to be able to get the reuse of the data which we funded. So I think that's going to be essential for things like being able to respond to disasters effectively, being able to respond to new diseases that hit the planet, and the big challenges like Alzheimer's, AIDS and cancer, which involve such a lot of information from so many fields being correlated, and the person who has the brainwave who makes the next step forward, being able to get hold of the data that he or she needs to be able to make that step. What we're looking for from the web data is, in a way, what we found from the web documents is a sea change. When we started publishing documents on the web, we were publishing documents on the web, so you could go and read the documents. But because you could do it with a click, because the data hypertext link could go to absolutely any document on the web, independent of who that person works for, or where they live, and what language they speak, because that hypertext link is so powerful, there was a sea change in how businesses worked. There was a sea change in how people ran their lives, how they booked flights, of how they ran their families. There were these sea changes in how people keep in touch with each other, and social systems change, and things which just could not be done become possible. With data, the sea change may be even greater, because not only are we allowing people to be able to access stuff more effectively from across the globe, be able to get at stuff which they haven't been able to get at before, but because this is data which can be manipulated, we can put machine power into filtering it down, and then allowing them to join that to other summary data to maximize the human's ability to see correlations or trends. It may be that the sea change will be greater. It may be that we'll find that with this sea of data, we will just be able to solve some problems that we haven't been able to solve before. We'll look back and we'll realize that it would have just needed a million clerks plugging away at the web reading, or reading science papers, for example, to ever stand a chance of being able to figure out to pull in that correlation, which was the clue to making that very serious step forward. So, I suppose I've got huge hopes for the long term. I think a lot of the people who are dreaming about this night, in the medium term, yes, we're looking to see enterprise move more efficiently, but also in the back of our minds, there's a very, very exciting long term.
Okay, now I think you have 3 videos watched today, and including the one we watched last time, you should have enough information to put together after your discussions today. This is what I expect you to do. This is something very important I want to see. You have 7 minutes time to do the table discussions, to put things together. And in each table, you have 1 minute's storytelling about what you learned from this open linked data stuff. Okay? Only 1 minute, each table, 1 minute. After 7 to 8 minutes discussions in your table. Now, it is highly suggested if you want to hold things up, okay, you use your tablet or whatever device on your table. You might want to refer to this couple of short video, okay? The 3 minutes for summary, okay? Tagging, okay? And social graph. And what we're talking about here, this could be the basics for you to put things together in your 1 minute storytelling. So go ahead, work among yourself, try to put together some ideas you collect over the past 10 minutes, okay, of our learning on this open linked data in the context of the next round of open linked data. And in the last video we saw, Tim earnestly introduced the term semantic graph. Okay, now characteristics, try to put them together with your table-based effort, okay? 1 minute from each table. We're going to start at 1 minute sharing exactly at 3:30, okay? So we have 5 tables, actually 6 tables, so we're going to spend 6 minutes all together for your sharing. It's your discussion time now. We have 7 to 8 minutes time. What do you get? And make sure if you need it, go to watch the previous videos on the tagging and summary in case you need it. Okay? Can you watch the videos? Have you ever tried it? Smartphone can help you watch it in case you need it. It's very good. Now, depending on the question you use beneath your storytelling, you might want to discover different pieces of information. So take it out from the videos for your own convenience. Very important that you know how to choose. You know how to choose the questions to answer. So during your discussions, allow me to take attendance for today. Kenny is not not here today. Sarah, thank you. Kara, thank you. Joanna, thank you. Yosemi, thank you. Lavi, thank you. Shelley, thank you. Nicole, thank you. Lena, thank you. Vicky, thank you. Helen, thank you. Joanne, thank you. Winston, thank you. Kathy, thank you. Cersei, thank you. Wendy, thank you. First of all, the main points, observed informations. Second is your interpretations of them, which is the question you need to ask. Finally, is the replications, reflections, and then into stories. This is inquiry-based learning, actually. So you have 3 more minutes to get things done, get your story ready. Thank you so much. This is a very hard-working class. Everybody is working very hard. Did you feel cold? Very good. A lot of the takers are already finalizing the story. Yes, this is an active process of IBM in actions. Very good. Make sure this is the O, you watch the video. Okay, you got some data. The I, you interpret what you got. Ask questions. And the A, you put together what you learned. This time in 1 minute. Are you ready? Okay, now let me walk to the camera, and I know that some tables already. So may I invite our students, so the first table, are you ready? If you're ready, you can help share. Introduce yourself.
My name is Vicky.
Thank you.
We think that data is including some of the Excel, image,
All right.
Excel, etc. And but what is the relation of this data? We think that first we package the data and then connect the data as a group.
Okay.
And then there are many groups so that it provides a global information.
Okay.
And the global information increase the opportunity of the financial market or the possibility of the invention.
Okay. Do you have any more to add? All right. So now let's listen to all the table first, and then we see if we have time for questions. So will you pass the microphone to any table of your choice? You can choose one table to pass the microphone. Thank you. Hello.
Hello. My name is Wendy.
Wendy,
We
yes.
see that link and tag of technology is that when we search for some information, it will automatically provide the connect information within. And all we have to do is click that link.
Okay.
So we can understand more about it and get more information within. Now Casey will tell the story about how to use this technology.
Okay, thank you. Thank you, Kathy.
Hi, the story is maybe you feel interested about someone in the Facebook and you can click him, and then you will open another website which linked the website you first choose.
All right.
And you can find his personal information and know him, make friends with him.
Okay, that's very interesting. I think you got the idea. Thank you very much. Could you pass the microphone to the table of your choice? Hi, Joanne. Hello.
Hi, my name is Joanna.
Joanna, thank you.
And I think that link data is an easy way method of publishing structured data on
Okay.
website.
Okay.
And then this is you let our data become more useful
Right.
and can be read. And all the data are connected
Right.
to others.
Okay.
And the website and the web, the links, the data. You
Okay.
look at other links related to other things.
Okay. So
Yeah, that's all.
the links to the data which have meaning, and then you can continue to look for the links which could link up the meaning. It's very interesting. Okay.
Which is alongside by
Right. Particularly in the context of social networks. Thank you. Can you pass the microphone to your table of choice? Yes, Nicole. Hello.
Hello, my name is Clara.
Yeah, thank you.
From the videos, we know that the data is about statistic, a website that have pictures and articles,
Right.
and you will, and then the website, because of the open data,
Right.
the different websites that share the similar information, they can link together.
Okay.
And in the video,
use the Facebook as a sample.
Okay.
And once you know someone, like for example Tom, you can click in there, and then you
Yes.
maybe find someone you would know that which means
Right.
he or she is your common friends. So
Okay.
so the website can share this comment, and you can find more friends from Facebook.
Okay. So it's also very connected. Hi, Nicole.
Hello, I'm Nicole. I want to talk about the semantic data and with the linked data. I understand that normally the web or the machines actually they cannot accomplish tasks without humans' direction.
Right.
But the semantic web is used to readily understand by the machines that allows data to connect together, and we can get the related information.
Right. So thank you, Nicole. You help us to get one step closer to what we expect. Hello. Winston, you want to represent something? Thank you.
I think linked data is like your Moodle page.
Okay.
Now our learning contract is wiki, yes?
Yes.
It is a type of linked data.
Okay.
And it can transfer one side to other side.
Okay.
And we can share our idea and connect it. And I think it is very useful.
Okay, I think it's very interesting to use the wiki to help us understand it. Thank you, Winston. Thank you. So, Yosemite, we have something to share?
I think the linked data, open data is shared information in a way that can be read automatically by the computer.
Okay.
Yeah, and this enables the data from different sources to be connected.
Okay.
And as we said that we have data like image, Excel, or videos, and connected to the web, like picture and text together.
Okay. Thank you very much. Does Lana have anything you want to add? Okay. That's okay. You can pass the microphone to Lavi. Lavi, help us to understand more.
No, it's nothing. Linked data allows data from different sources to be connected.
Right.
And also, it's by using the web, it allows data that is related to be connected.
Okay.
According to the video, they showed that there's a web page. When you enter or access a website, you normally find the web page. So what programmers do is they break down the page into small chunks so that the computer is able to understand this chunks.
Right.
Once it's coded up, the data is then linked from different websites.
Right.
And with search engines like Google, you can ask information just by typing in keywords.
Okay.
And when doing the research, for example, if you type on the search column, the computer will suggest for you like Taipei, Macau, or Taipei, Taiwan. So it gives you categories which makes it easy for you to choose what you really want.
Right.
Thank you.
Thank you, lovely. What about Shesi? You want to say something? You still have it's okay, you don't want to say anything, it's alright. It's okay. You'll take it, that's already answered. I think you have already put together very interesting pictures on this linked open data context. And indeed, it's something yet to be mature, right? Because that's a vision presented by Tim Berners-Lee long ago. And he's imagining actually a web, not just HTML pages, but data, raw data. And those raw data to be link it together, share it among audience, and we can have a much more intelligent web which could help us to answer questions more precisely rather than a bunch of results, okay, which is normally several pages long. So that's very interesting. Now, let me help you to understand one more concept. Understand. What are the two little angels helping us to understand? When they pick up a piece of paper, what did they do? They label it where it is, right? And when they label it where it is, that means it is where it belongs. It means what? Categorization. And what does it take to get something categorized? The little angel have to take a tag and put it where it is, right? So when we talk about open linked data, when so many people are contributing different kind of data, if we really want to look it up, we need what? Tags. If we really do not know what it is and where it is, we really cannot look it up. So tagging based on the category are very important. Okay? Two important concepts. Remember, did you put down these two important concepts? When we asked you for after you watched the video, tagging and authority, okay? Remember that, don't forget, all right? So it's very important. Now, to conclude today's class, let me give you this very important video, because it's not just the conclusions of this class, but it's an enhancement of the learning in the second learning contract as well as the first learning contract. Remember, this is the very last class to conclude your second learning contract, okay? So we need to provide some feedback. Now listen very carefully to this and actually watch this very carefully. 6 minutes.
If you wanted to learn about exotic birds, what might you do? You could go bird watching. Maybe you would visit the zoo. Or perhaps you learn by caring for a pet bird. These are examples of experiential learning, a theory pioneered by John Dewey. He proposed that learning can happen everywhere because experiences are everywhere. Dewey claimed that learning involves observing, doing, or living through experiences. This chart breaks down some of the essential elements of the experiential learning model. In experiential learning, learners decide the goals and what they have learned by thinking about what has taken place and their position within that process. The teacher's role is to create an environment that allows students to play a role in developing their own knowledge. In an experiential environment, teachers also help students analyze what has taken place. Immersive environments in Second Life, first-person perspective games, flying simulators, and scenario-based online tutorials. All of these examples attempt to create real-world experiences for learners. Before technology, learners were often limited to experiences in their own physical world. But virtual experience has expanded the concept of experience, making more experiences and learning accessible to more people, regardless of distance or physical capability. Let's revisit the birds example. Caring for a bird makes a lot more sense when you're actually doing it, right? And when someone more experienced shows you how to care for your pet bird and helps you understand why those techniques are important, that's situated cognition and cognitive apprenticeship. In situated cognition, knowing is inseparable from doing. In the example discussed, the knowledge of caring for a bird is best applied to actually caring for a bird. And when a master teaches the skills, it's similar to an apprenticeship. Teachers are experts or masters. They give students the opportunity to observe, engage in, invent, and discover in contexts that make sense. They model, coach, and provide scaffolding. Learners observe, apply, and gradually take on more responsibility for executing tasks within the authentic environment. More than 80% of 16 to 20-year-olds in the Swiss educational system learn through apprenticeship combined with 1 to 2 days of schooling per week. Similar systems exist in Germany and Denmark. The Dual T project shown here is working to improve the educational technology for this learning model. Suppose your school has been forced to cut funding for sports. Now imagine a principal challenging the student body to think of ways to fund the program. This is an example of problem-based learning. Problem-based learning, as well as project-based learning, are based on constructivism. They focus on real-life situations to encourage and facilitate learning. So what's the difference between project and problem-based? Take a look at this chart. Project-based may or may not be based on a problem. It is student-led. I think of science fairs. Problem-based is initially led by the teacher, who poses a single problem for all the students to solve. This makes me think of UIL academic competitions. Project and problem-based learning are learner-led. Students choose a path to learning and use critical thinking and collaboration to create knowledge. The teacher is a facilitator who challenges students with questions to encourage learning. Internet research, blogging, instant messaging, podcasts, videos, and social media are just a few ways students can demonstrate their learning when the project or problem-based approach is used. The iTech competition is a great example of using hands-on activities to focus individuals and groups in real-life situations. Layering in robotics makes it a good example of an instructional technology technique teachers could use to increase motivation among students to learn science and math. Let's revisit the sports funding cuts example. Imagine if students build their funding arguments by watching debates on funding. That's what a teacher using anchored instruction might do. Anchored instruction was pioneered by the Cognition and Technology Group at Vanderbilt University. It's based on social constructivist theory, and it's all about situating a theme, problem, or case study, and using storytelling video as a foundation. Technology is at its core. As with most of the constructivist theories, teachers using anchored instruction serve as facilitators. They provide the story, explain the activity, and provide questions or problems. This chart outlines the phases. Learners in an anchored instruction observe, identify information to solve problems, and work towards solutions, relying on cooperative techniques and community. Digital video is a technology that can help deliver anchored instruction. It allows students to chunk information from the stories using time codes in the video to know the information needed to solve problems. The most famous example of anchored instruction is the Jasper series. It uses a story with real characters to present a problem that the students must solve. They replay the story as many times as needed to find all the necessary data.
Very good introductions and also conclusions. Introductions of your first learning contract and conclusions of your second and your first learning contract. Remember, next week, starting next week, you'll be stepping into the first learning contract and look at the theme of the first learning contract, which lasts for 3 weeks. It is problem-based learning. What do you need to do to get started with first learning contract? You need to form a team. Make sure you form a team by connecting 2 pairs together. And except for one simple rule, the 2 pairs which contain 3 students cannot be formed together, but you have to find a pair with 2 students. I'm going to issue a call for formations call in the public discussion forum this week, and then each pair of you respond by telling me which other pair you want to be merged together to form a team before the end of this Saturday, okay? So make sure you don't get some of these.
This to do with the personal, the online personnel. I've noticed week 6,
yes.
week 5, 6, and 7.
Right.
Like the first 3 things, you ask us the same things from the week 5 to do again in general in week 6 and the same things in week 7, except the last 2.
You mean the number of items in the second learning contract?
No. You ask us the same question.
Yeah.
Doesn't make sense.
Which one?
Week 5, week 6, and week 7 for the online journal.
Yes, you have to select 1 week, your pairs to select 1 week. It could be week 5, it could be week 6, it could be week 7. So you can select 1 out of the 3. Okay?
But I'm thinking about the personal online journal, like for which one, like every week you have to journal the personal online journal?
Definitely, you can select the best you believe it is.
But you are asking us the same things.
Yeah, same thing.
Yes.
What exactly the question? Yeah. You mean the learning artifacts of the second learning contract, right? Yes. 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 Some of these are overlap. That's why I need to ask you to choose one that is distinct. Yeah.
So if it's overlap,
no. Even if it's overlap, it does not matter because you have to submit 1 week's journal. It could be week 5, it could be week 6 or week 7. But week 5 and week 6 have some overlap, and week 6 and week 7 have some overlap. Yeah, it does not matter. The overlap means you have a chance to enhance your understanding of the topic. So if you select, say, if this is week, now this is after class, does not be much. But these are some of the topics on a particular week. When you look at the topic of a particular week, you go back to reading. Okay, it's a reading. Right here. Right here. You go to the reading thing, okay? So if you go to the reading lanes, just press it. If you go to the reading lanes, you can come to reading list 4, 5, 6, and 7. You will discover that the questions overlap with this 2 week. Questions overlap with this 2 week. So when you submit the journal, it's based on either this one, or this one, or this one. You just select one. You do not need to do more than one. No, that is for the end of the semester or the end of it. But for this learning contract, remember, the only artifact in terms of learning journal is you have to do only 1 of these 3 weeks. That means submit only 1 of these 3 weeks. And week after it does not matter. this point because you have to look at the look at my teacher's message. That's much better. Go back to the other side. Yeah. That is the aftercard. That is not exactly the okay. This is still not delivered. Okay. Let's come to the teacher's message. There's a teacher's message. Sorry. Yes. Not this one. Go up. Right. You have to go to the teacher's message. Here we have teacher's message this way, right? So you go to this teacher's message. Okay. It tells you item number 1. Yeah, individual. And you choose one, okay? One of 3 ways. And the important thing is which you choose. Once you choose that way, you can share the number of questions inside that way with your learning partner. You do not do all, okay? That is very important. And but in terms of discussion this topic, you have to finish discussing 3 topics, 1 on each week. So that is a little bit more. But in terms of doing journalists, that's share. So use this as the basis. That is the simplest one. Thank you. Yes, your question you can still ask me. So I hope you understand what I mean by giving me the information on the teaming. And it's already 5 minutes to 4. You're free to go. Thank you very much. So when you come back next week, it's the current learning contract. Okay? And it's next Friday, you need to submit all. Okay? Thank you very much. So that's it today. For today's CISG114 Section 1 Web Technology and Life, date number 13, March the 27th, 2014.